What can the maximum number of digits be in the repeating block of digits in a decimal expansion of 1 by 17? Perform the division to check your answer. Now, it's asking the maximum number of digits. It's not asking you the exact answer, but what can be the maximum number of digits. You always have to pay attention to this maximum number of digits, not the exact answer. So when you divide 1 by 17, you get this as a quotient. This is a decimal expansion of this 1 by 17, where 058823529411767 is a block of 16 digits, that will repeat itself, and that is, we have placed a bar over these 16 digits. Okay, now in this case you have actually calculated that you have 16 digits in a block, but you can tell the maximum value without finding the answer. We discussed this thing in our earlier video tutorial, in the yesterday's tutorial, that whenever you divide a number, then if your decimal expansion is non-terminating, recurring, then the number of digits in a block that will repeat itself will always be less than divisor. Now in this case, your divisor is what? 17. So the maximum number of digits that can be present in a block will always be less than 17. That is, the max value it can be 16, right? It can be 16. So we have discussed this earlier. Look at several examples of rational numbers in the form p by q, where q is not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representations or expansions. Can you guess what property q must satisfy? Okay, a little long question, but don't get scared or don't get afraid of this question. It's very simple. First of all, it's asking of p by q, that is rational number where q is not equal to 0 and p and q can be integers. Okay, now if you remember, if you have two numbers, let's say it is a and b, and the highest common factor of these two numbers is only 1, no other number, it's 1, then these two numbers are actually called co-prime numbers. It's called co-prime numbers. Grade 6 mathematics, or relative prime numbers. Grade 6 mathematics. Okay, so what's the point here? The point is that it's actually asking about co-prime numbers. Okay, so I have taken some numbers here, okay, and on the basis of this we'll discuss that what property this q that is in the denominator should hold. Okay, look at these rational numbers: 1 by 2, 1 by 3, 1 by 4, 1 by 5 and 1 by 6. Here your division must be terminating. It must be terminating decimal expansions. This is important. Okay, if you divide 1 by 2, you'll get 0.5, or let me write it here, 0.5. It's terminating. If you divide 1 by 3, then you'll get 0.333 and so on. It's non-terminating, right? If you divide 1 by 4, you'll get 0.25. It's terminating. So this gets satisfied, this gets satisfied. Okay. If you divide 1 by 5, you'll get 0.2. Again, terminating. If you divide 1 by 6, then the answer you will get will be, like, if you divide, it will be 0.6 times 1 is 6, then you get 4, then 6 5 35, then 6 5 35 6, 6, 7, 42. So it will go on. It will again be non-terminating. Whatever you will get will be non-terminating, right? So this doesn't get satisfied. Okay, you just keep track of all these things. Now take this one. This is 2 by 3, right? This is 2 by 3. Divide 2 by 3, then you get 3 times 0 and 3, 6, 18, then again 2, 3, 6, 18, then again 2. So you get, in this case you get 0.666 and so on. So this is non-terminating. What about this one? 3 divided by 2, you get 1.5. This is terminating. So this gets satisfied, right? This gets satisfied. Now again we have two pairs of co-prime numbers, 2 by 5 and 5 by 2. Let's solve for this one, for 2 by 5. So if you divide 2 by 5, you will get 0.4. This is terminating. If you divide 5 by 2, then you get 2 to 4, 2.5. It's again terminating, right? It's terminating. That's why this also gets satisfied. Now let's take this 8 by 9. So when you divide 8 by 9, then 8 by 9 means 0.9872. You get 89872. So it's 0.888, and this. Now let's divide 9 by 8. So 9 by 8 means 8 times 1 is 8. Then 8 times 1 is 8. Then 8 times, sorry, this is 8 times 1, 8. And then here it should be point. So 8 times 1 is 8. Then 8 times 1 is 8, 2. Then 8 to 16. Then this is 4. And this is 8, 5, 40. So this gets divided. This is 1.125. So this is terminating. So what's the point here? If you look at all these, which have actually terminating decimal expansions, this one, so this was 1 by 2. Focus on this one. This is 2. Okay. Then this one, it was 0.25. This is 4. Okay. This is 2. 2 means what? 2 raised to the power of 1. This is 4. It means that this is 2 raised to the power of 2. Then you have 0.2. It was for this one. This is 5. This is 5 means 5 raised to the power of 1. Okay. We are only checking for all those which gave us terminating decimal expansions. Okay. Now when you come for this one, 0.666, it was for this one. 1.5 was this one. In this case, if you look at this, this is 2 raised to the power of 1. Now again 0.4. In this case, if you look at this one, this is 5 raised to the power of 1. This is 2.5. It was for this one. So in this case, the denominator is 2. It means that it is 2 raised to the power of 1. Then it was 0.88. It was not satisfied. Here it was satisfied. If you look at this one, this is actually 2 raised to the power of 3. It means that from the numbers that we have chosen, and from these numbers, from these rational numbers, if you find out their decimal expansion, then one thing is common. Only those rational numbers who have the denominator, that is, we are talking about the q, whether if it is a power of 2, like in this case it was 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 1, 2 raised to the power of 1, 2 raised to the power of 3, or it is a power of 5, like here it is 5 raised to the power of 1, 5 raised to the power of 1, and you can find similar numbers. Only those numbers, if they are co-prime numbers, this is very important, where p and q have to be co-prime numbers. Okay, so only those pair of co-prime numbers where denominator is actually either the power of 2 or the power of 5, only that will give us terminating decimal representations or expansions, no other number. So this is a property that you have to remember, that if you are taking a pair of co-prime numbers and if you want its division, its quotient to be terminating decimal expansion, then the denominator has to be either power of 2 or the power of 5. Classify the following numbers as rational or irrational. Now this is square root of 23. Now we'll always take, for our discussion, we'll only focus on the positive square root, not on negative, because we know that if you have to find a square root of 4, the answer is plus 2 also, minus 2 also. But we'll limit our discussion only to this positive numbers. Okay. So here this is square root of 23. Now square root of 16 is what? 4. And square root of 25 is what? 5, right? Is there any other integer between 4 and 5? No. After 16 you are getting 25. So where is 23? It's actually then tells us that this is actually irrational number, since you cannot find its square root. Therefore this is irrational number. This is irrational number. What about square root of 225? The square root of 225 is actually equal to plus 15 and minus 15. And as we said that for our discussion, we'll limit our discussion to only positive numbers. So plus 15 is the square root of this number. Therefore, this is a rational number. What about 0.3796? Okay, this decimal expansion is actually terminating. It is actually terminating, right? 0.3796, and that's it. Therefore, we say that this is actually a rational number. What about this one? This is 7.478, 478, and so on. It means that this is actually 7.478, and this bar will be above over 478. It tells us that this block of 3 digits, that is 478, will keep on repeating itself. That is why this is non-terminating recurring decimal expansion that makes it a rational number. This is a rational number. What about this one? Now in this case, this is 1.10, then 100, then 1000, then 100001, and so on. But in this case, we cannot form a particular block that will repeat itself. We don't have a particular block. Here it is 10, but then it is 100, then it is 1000, then it is 1 4 times 0. So there is no particular repetition of a particular block. It means that this is actually non-terminating, non-recurring. Why non-recurring? Because we don't have any particular block that repeats itself. So non-terminating, non-recurring decimal expansion is actually what? Irrational numbers. Again, we have discussed all these things yesterday. So in our earlier video tutorials, we have covered all these things. Please check our previous video tutorials. So this is irrational, this is irrational, rational, irrational, and so we have this also rational. 3 rationals and 2 irrationals.